Prototyping was a very hard challenge for our group. To overcome this obstacle, we decided it would be wise to split into two different groups. The first group worked on the arm extender, which would ultimately allow us to do a pull-up. The second group worked on the base operations, which would allow us to climb up the mountain. While in discussion, the arm group exposed that they have not found a suitable way to maintain enough torque to lift the robot. While researching, we found out that the rack and pinion suits are neat, so we implemented it. The base group had issues also. They discovered due to the lack of friction, the robot won't be able to climb up. Jagan suggested to buy all-terrain wheels, and after consideration, we did. Later, Matt and Jagan will talk about the properties of these functionalities.
The main focus of our robot is hanging on the top bar during controller mode and resting on the ramp during autonomous mode. Our robot has a very agile design, and we believe that it will be able to climb the ramp easily. Also, we thought that the other methods of getting points simply were not doable every game. We thought that we couldn't count on being able to put debris into the boxes every game. So we thought that this would be a surefire way by designing our robot to climb up the ramp. Also, not many other robots will be doing this, and 80 points is a huge deal. So we thought that this would set us apart from the other teams and make sure that our robot is the best.
As you can see, our robot uses large all-terrain wheels to go up the mountain with ease. Another unique aspect of these wheels is the way they are driven. As you can see, this robot uses all-wheel drive, meaning each wheel is driven. The two wheels is driven by just one motor. This is accomplished by having gears connected to the motor, which eventually connect up to gears on the wheels. This is very helpful because if we only use two motors for our drivetrain instead of the traditional four, we have two motors that we can use for the arm and rack and pinion. And this is great because we only had access to 4 motors and 2 motor control.
Our robot has a unique arm that utilizes many different mechanical techniques. The arm has a rack and pinion that we utilize to pull our robot up the mountain. It catches the mountain on the many different hooks that are attached to the arm. There is a button that is pressed whenever the arm goes too far in or out in order to stop the arm from going too far out or in. There is also mechanical stops as a backup to them.
In order to work more efficiently, we split into two groups. 3 of us work on the arm of the robot and 2 of us work on the central body of the robot. Periodically, we meet and discuss significant parts of the arm and body that have to be dealt with together. One member of our team, Derek, is a great programmer and did most of the coding for our arm and body. Subsequently, Matt and Jagan with prior FLL experience are very good at problem solving and building. They built most of the body, as it is a key part of our robot. Our dedication and team spirit, alongside the enthusiasm we bring to FTC meets, makes our team unique. Although regardless of whether we win or not, in the end, the most important thing is the fact that we persevered and worked hard through any challenges that we faced.